Good evening. I've just set up a 2 megapixel camera currently, the standard lens, light source, and then I've created, you can just see here, this bit of plastic that I had lying around the office. You can see there's a hole just inside there, very similar to the hole that you get on your products for screwing it in. So then I just wanted to show you like a standard image that we've got currently. This is kind of a little bit overexposed, and maybe if I zoom in a little bit, you can see there's kind of a little bit of glare inside, and if I just open this up a little bit more, and this is kind of what's happening in your situation at the moment. Maybe it's a little bit too bright, the image, because you're getting like a kind of hazy area down inside, and then also because your aperture's open, it's also reducing the depth of field. So we need to close the aperture off. So obviously on the camera I've got here, I've got a manual aperture that I can actually adjust, so I can just simply turn it a little bit more towards the closed direction. Come back over here and I'll just fire the camera again, and you can see now it's going much darker. So maybe I've gone a little bit too far here now. I'll just open that back up a little bit, and we want to find like the great compromise where the inside edge is still very dark and this is very bright outside. Obviously, again here though, you notice there's a lot of glare, and the more I can close that off, basically the better the depth of field is going to be. So I'll just do that, and then let's just make sure we've got that image really crisply in focus. And this is something I didn't see on any of the images you presented the other day, that it was nice and sharply in focus. But you can see now this edge is really well defined, so it's going to make a nice stable detection. So the second thing I can actually do on here, obviously on here you've got this kind of halation as well, and I've actually got like additional images I can create from this that actually remove that halation completely. So this is just from the same set of captures, but you can see here the halation now is completely gone. I'll just go back to the normal image again, and this is the normal image, and you can see all the halation is back. So I'll just explain how it's actually doing that. So I'm just going to the setting mode here, and this is actually what we call a function called LumiTrax. And LumiTrax basically operates like a shape from shading kind of technique, and by shining the light from multiple directions, we're able to actually eliminate the glare. So let me just show you the actual images that we've got here. So first of all, we shine with the light from the right hand side here, from the top, from the bottom, and from the left. And as you can see on each image, the glare is actually moving to a different orientation where the light is actually shining from. And then just to maybe show that in a simulation, you can see, like if I really slow it right down, you can maybe see the light actually pulsing around. If I just trigger that again, and maybe from above it's maybe easier. So I've really just slowed it down now so you can actually visualize that. But if I just put it back to kind of its running speed, and if I just trigger it again now, that one capture, that one flash that you just saw there, that's all 5 images. So it's taking the image with the light from the top, the bottom, the left, the right, and all the lights on all together. Then from that collation of images, obviously as I showed earlier, we're able to produce the texture image, which completely removes like this over-halated area, which is there. And then also we've got what we call a shape image, and this highlights the edges very well. So we could also use this as well as another option really, but I think realistically we should just be fine with the texture image that we've got there. So this is a couple of improvement points that could be made to the system as well.